Good morning everyone. I am G. Likita from CSIT. Today my AIT Techtalk concept of probability and statistics is events defined by random variables. Random variable. First of all, let us know what is meant by random variable. A random variable is also called random quantity, aleatory variable or stochastic variable. It is a mathematical formalization of a quantity or object which depends on random events. Informally, randomness typically represents some fundamental element of chance, such as in the roll of dice. It may also represent uncertainty, such as measurement error. However, the interpretation of probability is philosophically complicated and even in specific cases is not always straightforward. The purely mathematical analysis of random variables is independent of such interpretational difficulties and can be based upon a rigorous axiomatic setup. In the formal mathematical language of measure theory, a random variable is defined as measurable function from a probability measure space called the sample space to a measurable space. This allows consideration of the push forward measure, which is called the distribution of the random variable. The distribution is thus a probability measure on the set of all the possible values of the random variable. It is possible for two random variables to have identical distributions but to differ in significant ways. For instance, they may be independent. Let us know what is meant by random variable. Random variable is a measurable function x mapping sigma to e from a set of possible outcomes sigma to a measurable space e. The technical axiomatic definition requires sigma to be a sample space of a probability triple sigma fp. See the measure theoretic definition. A random variable is often denoted by capital Roman letters such as x, y, z, t. The probability that x takes on a measurable set S subset or equals to E is written as given. Standard case. In many cases, x is a real valued equals to r. In some context, the term random element is used to denote a random variable not of this form. When the image of x is countable, the random variable is called a discrete random variable and its distribution is a discrete probability distribution, that is, can be described by a probability mass function that assigns a probability to each value in the image of x. If the image is uncountably infinite, then x is called a continuous random variable. In the special case that is absolutely continuous, its distribution can be described by a probability density function which assigns probabilities to intervals. In particular, each individual point must necessarily have probability 0 for an absolutely continuous variable. Not all continuous random variables are absolutely continuous. A mixture distribution is one such counter example. Such random variables cannot be described by a probability density or a probability mass function. Any random variable can be described by its cumulative distribution function, which describes the probability that the random variable will be less than or equal to a certain value. Extensions. The term random variable in statistics is traditionally limited to the real valued case. In this case, the structure of the real numbers makes it possible to define quantities such as the expected value and variance of a random variable, its cumulative distribution function and the moments of its distribution. However, the definition above is valid for any measurable space E of values. Thus, one can consider random elements of other sets E, such as random Boolean values, categorical values, complex numbers, vectors, matrices, sequence, trees, sets, shapes, manifolds, and functions. One may then specifically refer to a random variable of type E or an E-valued random variable. This more general concept of a random element is particularly useful in disciplines such as graph theory, machine learning, natural language processing, and other fields in discrete mathematics and computer science, where one is often interested in modeling the random variables of non-numerical data structures. In some cases, it is nonetheless convenient to represent each element of E using one or more real numbers. In this case, a random element may optionally be represented as a vector of real valued random variable. For example, a random word may be represented as a random integer that serves as an index into the vocabulary of possible words. Alternatively, it can be represented as a random indicator vector whose length equals to the size of the vocabulary, where the only values of positive probability are 1 0 0 0 1 0 1 0 0 0 0 1 0, and the position of the 1 indicates the word. A random sentence of given length n may be represented as a vector of n random words. A random graph on n give vertices may be represented as a n cross n matrix of random variables whose values specifies the adjacency matrix of the random graph. A random function f may be represented as a collection of random variables f of x, giving the function's value at the various points x in the function's domain. The f of x are ordinary real valued random variables provided that the function is real valued. For example, a stochastic process is a random function of time, a random vector is a random function of some index set such as 1, 2, so on n, and random field is a random function on any set. Discrete random variable. Let us know what is meant by discrete random variable. Here the discrete random variable means here we are going to take an example or we are going to take an event, then the possibilities which are there should be in the finite value, then it is known as discrete random variable. Here there are some examples of the discrete random variable. Then here is the statement, or here is some examples of discrete random variable. The most taken example for discrete random variable is coin toss. Here the outcomes which are possible are heads and tails. If it is heads, then 1, if it is tails, then 0. This is one of the outcome and this is another outcome. Here whatever the outcome is for coin toss, it will be finite, so it is discrete random variable. Then dice roll. Here the dice roll, the maximum possibilities of dice roll is 36. Whatever the condition is, the possibilities are limited, so the dice roll is also discrete random. Then continuous random variable. Let us know what is meant by continuous random variable. Actually, the continuous random variable means the condition, the possibilities of the probability or the possibilities of which we are getting probability should be infinite, and it will be in the given interval. If we give the possibilities up to 0 to 20, then it will be up to 0 to 20 only. If we don't give any interval, then the probability will be infinite. If not, it will be into 0 and 20. So this is called the continuous random variable. And there are many examples for continuous random variable as given. And here are some of the formulas or some of the examples by using functions in the continuous random variable. Then the mixed type. A mixed random variable is a random variable whose cumulative distribution function, that is CDF, is neither discrete nor everywhere continuous. It can be realized as a mixture of discrete and continuous, in which the case CDF will be the weighted average of the CDF of the component variables. An example of a random variable of mixed type would be based on an experiment where a coin is flipped and a spinner is spun only if the result of the coin toss is heads. If the result of the tail is -1, otherwise x equals to the value of the spinner as in the preceding example, there is a probability of 1/2 that this random variable will have the value -1. Other ranges of values would have the half the probabilities of the last example. Most generally, every probability distribution on the real line is a mixture of discrete part, singular part, and an absolutely continuous part. The discrete part is concentrated on a countable set, but this set may be dense, like the set of all rational numbers. And here are some of the functions of random variable. Example, fy of y equals to given something. If it is increasing, this is the condition. If it is decreasing, this is the condition in this statement. These are also some of the functions of the given random variables. Let us know what is meant by the event. In probability theory, an event is a set of outcomes of an experiment to which a probability is assigned. A single outcome may be an element of many different events, and different events in an experiment are usually not equally likely, since they may include very different group of outcomes. An event consisting of only single outcome is called an elementary event or an atomic event. That is, it is a singleton set. An event S is said to occur if S contains the outcome X of the experiment. The probability that an event S occurs in is the probability that S contains the outcome X of an experiment. An event defines a complementary event, namely the complementary set, and together these define a Bernoulli trial. Did the event occur or not? Typically, when the sample space is finite, any subset of the sample space is an event. However, this approach does not work well in cases where the sample space is uncountably infinite. So, when defining a probability space, it is possible and often necessary to exclude certain subsets of the sample space from being events. This is some of the example of event like red and black at the same time without being a joker, the five of hearts, a king, a face card, a spade, a face card or a red suit, a card. Here is one of the example. And then events in probability spaces, and how the events will be in the probability spaces. Like if the coin tosses, what are the possibilities? Here the possibilities are called as events. Next, here is a note or notation. That means what is the notation for event? Here is it. Thank you.